So problem 9 is a continuation of problem 6, where we were finding the x-intercepts. And recall that to find the x-intercepts, we set y equal to 0, and we solve. And then the two roots or solutions that we get, we're going to go ahead and express those in final terms as points, because x-intercepts are points. They're points where the parabola intersects the x-axis. So let's start with problem 9, part A. We have, let's try that again. We set this equal to 0. And looking at it, the AC method is not going to work out, and tic-tac-toe is not going to work out. And so we're going to just be stuck with the quadratic formula. So A is positive 1, B is negative 3, C is positive 1. Here's our blank setup for the quadratic. Here it is filled in. We simplify. And this in turn becomes 3 plus or minus radical 5 over 2. Now, if we were looking for the roots or the solutions, we're done. However, we're looking for the x-intercepts. So that would be 2 points. There's this first point, 3 plus radical 5 over 2, comma 0. And the other point would be 3 minus radical 5 over 2, and 0. So these are the two x-intercepts for part A. For the record, if you look at problem 7, part A, it's the same exact quadratic. And did you note that in part A, when we were trying to predict how many x-intercepts there would be, it said that we would have 2. And here they are. Here are the 2 x-intercepts. Part B, we're going to set that equal to 0. And this actually happens to work out with the AC method. I have a plus 1 on the top and a plus 2 on the bottom, and that's a plus 1 and a plus 1. These two multiply to a positive 1, they add to a positive 2. So B becomes x plus 1 equals 0. We separate and solve. And we note that the answers are repeated. It's a repeated double root. So as far as the x-intercepts are concerned, we would say negative 1 comma 0 and negative 1 comma 0, but it's the same exact point. So really, I don't need to write them both out. The answer is just one answer. And again, if I would refer you back to problem 7 part B, which is the same quadratic, in that case, we predicted there would be one x-intercept, and here it is. Part C is just kind of a mess. So if we do AC method, there's nothing that I can multiply with 4 that'll give me a 1. And the tic-tac-toe method will prove unfruitful. So we're going to have to do the quadratic formula for this. A is equal to positive 1. B is positive 1. C is positive 1. Here's the quadratic formula, blank. We're going to go ahead and plug in a B right here, B right here. AC, so it's positive 1, positive 4, and then 2A. Awesome sauce. Let's clean this up. This is a negative 1 plus or minus 1 minus 16 over 2, which is a negative 1 plus or minus negative 15 over 2. And I think something's working here because you thought it before I said it. But you thought to pull out an I because there's a negative inside. So good for you. Yeah, I'm talking to you. And because 15 is prime, well, that's it. So here we have to take a moment, pause, and reflect. What the heck just happened with part C? Because if you look at problem 7, part C, we predicted there would be no x-intercept. But we have some answers. Well, but it's imaginary. Okay? So what this is telling me is, yes, I have answers here. I have a solution. I have 2 solutions, but they're complex. They're not real. Okay? Since we pull out an I, that's an imaginary number, that's a complex number, then we have no real roots. And if we have no real roots and we just have complex roots, if you refer back to your table, that means that there are no x-intercepts. Right? So if we look at this graph is never going to touch the x-axis. Okay? It's going to be something probably like this, right? And it'll never touch the x-axis, so it'll never have any x-intercepts. So here we saw an example of each, right? A, which had 2 x-intercepts, B, which had 1 x-intercept, C, which had no x-intercepts. And I would strongly suggest referring back to problem 7 to see those discriminants and how we use them to predict how many x-intercepts we would have. For your summary, is it possible for a quadratic to have no x-intercepts but still have a solution or roots? Explain.